Welcome everybody to Robot Builders Night Virtual for August 5th, 2025. Tonight we'll do the usual roundtable presentations with anyone that's got something of an update on their projects. And after that, we'll open it up to open discussion questions. So we'll start off with David Ackley.
Okay, this month I'm celebrating my 1-year anniversary, and as my wife asked me what I would like, and so I was floundering around, and I decided, okay, I'll try a Sunfounder PI dog. And I wondered if anybody had experience with those.
Nope.
No.
The Sunfounder robot dog, I believe there's a couple guys in the club that do have them. Paul is one, I believe, that has one. And I think Doug Key as well has one. They both have varied experiences. I know they both run them in the Quick Trip contest that we do in the spring. I don't know if they ran them this year in that contest.
I don't think they did. I think both of them run off Ross too, don't they?
I'm not sure if they ran on
Ross does.
I didn't think so.
No.
Really? Ross, the little dogs, aluminum dogs?
Yeah.
Conceivably, they can run Ross, but the basic one that they have the software for just runs MicroPython.
Okay, I'm sad to say we can't help you out more than that, David. But maybe you could reach out to the guys. I don't know when Doug is coming back. I know he's been gone for most of the summer. And Paul as well. Paul does a lot of traveling in the summer, but he's usually, I know he monitors the Discord server. So you could reach out to him there.
Okay, I'll try. I've got their emails for both of them, so I'll give them a shout out. Thank you.
Okay. I'm, like I say, sorry we can't help you more than that.
What kind of information are you looking for, David? I mean, the implementation, the building of it?
You're muted, David.
I see your lips moving, but I don't hear
There you
anything
go.
coming out.
No, I was just interested in, what their general experience has been. I've looked at some videos that look pretty interesting, but anyhow, I thought I'd talk to somebody who had hands-on experience.
The only advice I can remember them giving is don't drop them.
Okay, yeah, that looks like probably a good idea.
The legs apparently break easily.
Yep, I can imagine. Thank you.
I think the legs are just held on by the servo horns, so that gets a little iffy when you drop them.
Yes, that's what it looks like.
Make sure you get Metal Gear servos if you can.
Well, I think it comes with it, like it comes completely assembled.
It comes with Metal Gear servos. Okay, well, thank you.
Okay, thanks, David.
Mhm.
Scott, you're next.
Thanks. So I've been working on belt chair. I actually have RTK working on it, and basically a prototype. I have a base station that I've built, and I've been able to link it up. So now I'm kind of integrating it into the robot platform, because you have to get that data to it somehow, right? And I'm also kind of, I have Turd, so I have 2 robots I want to be able to leverage the same base station from. So I started looking at the XB modules, and you can do like micro meshes or, mesh network kind of things. And I was wondering if anybody had any experience with that, any advice, because there's a couple of different approaches apparently you can take. And I've been doing a lot of reading on it. So, yeah, so no one, I see everyone shaking their head. No one's messed with XBs.
I used their Holy Bros, I think. It's considered a telemetry radio, but it's just, single point to point. It's at least that's the way I'm using it.
Yeah, and that's the way, I've already, I've had a couple of older, they were made by a company called Lynx that I've been using. And I don't think Lynx is around anymore. But then when I started looking at the Arduino Simple, RTK, because I had that kit, that was the GPS radio I've been using. But I've never used it, set up a base station. So, I mean, I've had just point to point, I have the telemetry information that comes back to my PC, and I can also, change parameters as well on the fly through that wireless link. But I didn't want to have just another dedicated link back to Belch just for the correction data for RTK. So I was looking at integrating it into that data flow, and then I got to looking at the XB radios, and there's a lot of different, to share information from node to node and joining this network and that network. So, so I guess you guys aren't going to be any help.
Probably not.
So I guess I'll keep reading and keep fumbling. I just got my box of modules today. I had a set up just point to point direct, back and forth. And then I was integrating it into Belch, and I forgot the fact that it's 3.3 volts and the radio I'm replacing was 5 volts. So a point to point network with only one radio doesn't work real well. So I had to get a whole nother box of them. And that's why I was started to think, well, it'd be great if I could create a mesh network. Because it was really impressive, Paul, last year with his RTK, and really no other sensor, right? Other than I think he had a bumper. And when I had the RTK linked up, it's showing, 0.06 meters of accuracy. So, that's pretty damn good if you ask me. But I think my next step is to have something where you can map them, because I think now the next real data error point is, what do you feed into it? What location are you actually going to? Now that you can accurately go to a position, is that value you recorded accurate? So
Paul, last year, Paul found a loophole, and the loophole was, before the contest, you can't take your robot to the spots to map them. So he was able to pull out the RTK module,
pull the guts out of it, yeah,
and go to each spot.
Well, these radios, because I've got the module here, they're quite expensive. So, you don't want to just have one for every purpose. So,
right.
But there again, I kind of been able to think, well, I only have to pull the radio module and, an XP radio link, because that's part of the whole process, right? And you not only need the radio link during the run, but you're going to need the radio link while you're mapping the actual cone location. So you kind of have two purposes. And I think Paul just pulled the whole guts out of the robot and was walking around the the course with it, right? Which, okay, fine. Now that we have a precedent, you know,
Isn't it the same thing?
but then again, you know, I'm still kind of looking at the logistics. Okay, so you're walking around with a GPS modem and an XB wireless link, but you still have to record that data point, right? So I think Paul was using Wi-Fi for everything he was doing, wasn't he? Yeah.
Don't know.
So you know, it'd be much easier to share data through that. So that's kind of what I'm working through now, is kind of integration of it. But it was amazingly simple to set up the RTK, to be honest with you. You know, Arduino Simple has some instruction, you know, I have video or instructional videos, and I found a couple of online things. You know, their uBlot or uCenter software is a little clunky. And I will tell you, do not use uCenter 2 for the F9s, because it'll kind of work, and you'll set it up to say, okay, send out these messages out this port, and as long as you have power to it, it'll work fine. But as soon as you cycle power, all that goes away. And you can even go in there and you can declare what version, you know, is this RAM or is this flash? Where do I want to save this configuration to? And you save it to flash, and every time you reboot it, it just goes back to the factory defaults. But if you go back to the uCenter, the original uCenter, it works fine. Everything, the uCenter, the original uCenter is a little more clunky, but it even says on the uBlock site, you know, for the F9, F8 series and below, and then the current series and above the F9s is what uCenter 2 is targeted for. But if you're just monitoring data and watching the data coming back, it seems to work fine. But if you're trying to configure it, oh, it's frustrating. It took, you know, that was a week worth of playing around with it. And then I finally saw the note, you know, well, you got to use uCenter 1, the original uCenter. So definitely something to keep in mind if anybody's playing with those, because I know SparkFun makes a really nice little F8 module that can get, you know, a few meter accuracy. So the uCenter is really helpful in programming it and setting it up, all the messages. So anyway, that's all I had.
Yeah, this was my base station. So the in the cardboard box, it was the Cutie Pie, the radio, and oops, message just came up. Oh, and then the that's one of the M8 modules from SparkFun. One of the things that I thought was kind of neat about this with using UBX protocols and sending, you know, the RTK information across, you could actually hook the radio up to, you know, in this case, I'm hooking it up to a Cutie Pie, and then, you know, USB connection into my laptop. And you could actually look at the UBX protocols and it would recognize them. So at least you kind of got a warm, fuzzy feeling that, okay, what I'm sending is the right thing, and this tool is interpreting it as, you know, the RTK information that you need.
Well, the RTK information is actually sent by the RTM3, I think it is, messages. So yeah, any of the NEMA-based messages or text-based messages, because all of the correction data is all just straight binary.
Right. Yeah.
And this is actually the base station that I built. And you have, you know, the active antenna at the top. And I was actually reading one of the uBlock application notes, and they recommend highly having a symmetrical round ground plane that the antenna sit on. And they were showing too that if it's on a non-spherical type surface, it can actually skew the satellite signals. Like they showed an example of it being on the, like a corner, kind of like what I have on my robot, right? It's sitting on the corner of, a piece of aluminum. Now it was hard to say how much error that's going to generate or what's that's going to do. If I can maintain 0.06 meters of accuracy, I think I'll still be okay. But I was able, on the base station, I was able to put the round plate on there, the ground plate as they call it. And then I put all the electronics into the little box here. It's just got a battery and the transmitter and the GPS radio. So it's ready to go. Like I said, I'm just trying to integrate it into the, the whole platform as far as the wireless link. Because like I said, I don't want a unique link. And you can actually see the GPS antenna this is the GPS antenna here, and it sits right on the corner. So I have plans. I'm thinking about building kind of like a fly bridge, an antenna bridge here, because I also have the BeagleBone AI64 board running in here now. I've got a new interface board for all the serial links, and the BeagleBone has native CAN on it, so I'm able to talk to my H bridges over CAN natively through. Because before I had a microcontroller that was talking serial to the Raspberry Pi, and then it was translating that into CAN, and it was kind of clunky. And this is like a quad core TI. You can actually run Edge AI on it, which is ultimately the plan. But between getting that platform up and running and getting the RTK integrated, I didn't want to deal with the AI on it yet. So that maybe next year that'll be ready. But like I said, I still got some work to do on the chassis, integrating the new antennas, because with the new AI board, I have 2 Wi-Fi antennas. It's kind of hard to make out in the picture. But I got to mount those somewhere too. And that's why I was thinking about building like a fly bridge set up above, behind the sensor box, to house the Wi-Fi antenna. And then I was going to move the GPS antenna up here as well, because with the RTK, you're actually sensing the location of the antenna, right? So with the antenna way back here in the back corner, doing the kind of the offset of the math would be, a little bit more complicated than if it's positioned here in the center, right, more close to more of the center of the robot. So I think it makes sense to move that as well. I may, build an additional, tower so that I can have a spherical plate for it. But, being right between a couple of Wi-Fi antennas, I don't know how much that's really going to affect it. But I guess we'll find out. It's a work in progress.
Yeah, I want to say these were the 400, I guess it's 433 megahertz. So what the 2 the telemetry radios, I think, worked at 400.
They have to be 915 in the US, 433s in Europe.
Yeah, you might.
Yeah, you have to. I think Canada is 915 as well. I don't know, Pat, if you know, but
yep.
Yeah, and I believe that's what I read as well.
Yeah.
Yeah,
Don't let the
915s. I
FCC
thought
catch you using a 433 megahertz radio around here.
Usually those are so small a wattage that I don't know if anyone would even notice.
Yeah. Well, even the XBs that I have, and it's interesting because XB sells a lot of different versions of radio, and it's very difficult to try to distinguish between them, because now their latest Model 3, I think they call it, it's multi-band, right? So you have like the Wi-Fi band, you have a BLE band, and I believe you still have like a a 915 megahertz, band as well. And you can configure the radio to talk multiple protocols. And I don't know all the details, but I was reading through the data sheet and my eyes started bleeding. And I said, no, I'm just going to go back to something more simple. So I'm the ones that I'm using are actually the ones that Arduino Simple sells with their kits, which is basically the XB Pros, they call them. And direct line of sight, they say they're good for what is it, like 2 miles? It's quite a ways. So, and they're high speed because the older radios I've been using, like I mentioned, they're fixed at 115, or I'm sorry, 57.6 baud. And these XBs, I mean, you can run them at 250 K baud if you want. I haven't been able to really test the throughput because that's probably a bigger thing than the baud rate is, how much data can you really push through it? And that's still a little unknown. And I was going to ask anybody with XB experience if they know that, but I guess I'll have to report back and let you know. Because between the correction messages and all the data that I push back, the telemetry data that I normally push back from the robot, there's going to be a fair amount of traffic on there. And that's what I was going to test when I blew up the radio that I had. So that test remains to be seen. But like I said, more to come on that, I guess.
Looking forward to hearing your progress on that.
Well, my goal is to actually get a perfect score again this year, because ever since I've started upgrading what started out to be burp, I hadn't got a perfect score yet. So all the upgrades apparently aren't working.
But think of all the learning that's been done, that's the key thing.
Yeah.
All the learning.
I mean, I'll keep that in mind. I mean, it took me over 2 weeks to get all the pin muxes working on this AI 64 platform. That was, I don't know if anybody's dealt with device trees and, building their own. And yeah, because if you screw up, it just plain won't boot. So it's like, okay. So I had, in the Beagle Bones have, eMMC memory. So you can either boot off of the SD card or you can boot off of the memory. So what I would do is I would load the SD card into the eMMC and then start poking away at the device trees. And if it blew up and wouldn't boot, then I would just plug the SD card back in and just copy the SD card back into eMMC and start over. And it was a painful 2-week process. And I finally got it all figured out. A lot of details, probably no one cares about here, but yeah, that's like I said, I don't know if anybody's ever had to deal with device trees. I've dealt with them at work a couple of times, and it's always a beating because it's basically you run it through the compiler and it just says no, syntax error, no, not found. It doesn't give you anything about, it gives you a line number is all it gives you. It's like, okay, this line is nope. It doesn't give you a clue what's wrong with it. And especially like if you have conflicts between pins, that's when typically the things go really bad in a hurry, especially if you're conflicting with a system pin or a pin that's used for like the eMMC memory and it's not documented very well. And that's the other thing about the BeagleBone platform that I've found is, the documentation isn't anywhere close to what like a Raspberry Pi is, or, the community is just not that big. So you really have to sift through things that may not be that relevant just to kind of get an idea of what it's supposed to do. So yeah, it's a difficult journey to take, but I tell you what, it's a nice platform. I still like it. For me, being able to send out CAN messages from without some sort of interface bottleneck is a huge plus, because I do it. There's a lot of CAN traffic on my network, so hopefully I'm turning the corner and making it all work. We'll see. Because I mean, it's not but what, 3 months away, 3.5, something like that, right? So be here before you know it.
Yep.
I'm in the process of putting together a new microcontroller for the robot as well for that event. So we'll see how it goes. Not nearly as complicated as what you're working on.
Well, that'll be something.
Well,
to hear
it's a convalescence of 10 years of tinkering with it, so just give it some time, Pat. You'll get there. Because you keep adding, layers of crap on top of layers of something, and then it's like, oh, well, this would be better, or this, and it's just it's an obsession.
I'm taking all the low level functions out of the Raspberry Pi, and I'm putting them all into a microcontroller. So basically,
That's
the
good.
Raspberry Pi will handle the high level communication stuff, the cameras, the stuff like that, even the GPS. But the low level onboard stuff will handle the motors.
And that's where CAN bus really, comes into its own, because you can, that's one of the reasons why I have separate H-bridge boards, right? And it's just a CAN bus connection to the main CPU. So all of the encoder, all the, PID loop, all the PWM control, all the, encoder feedback, that's all done in a microcontroller, just like what you're saying, but it's all distributed, right? So and this the exact same code that runs in both H bridges. I have some jumpers that I tie in and basically address the board, so I know whether it's left or right. But that's all based on the CAN addressing.
Okay,
so
yeah.
The right board has one set of addresses, and the left board has the other, a different set of addresses. The message structures mean the same thing. So it's kind of the same thing. And I've done that with, like sensors, time of flight sensors. Those are kind of difficult. The I2C ones, I think, like Mike uses, make, kind of offload some of the real-time functions. But like a lot of those have interrupts that say, okay, I have a sample ready. So how do you do that in a Raspberry Pi? The interrupt response on a Pi, especially if you're trying to use Python or something like that, it's stupid slow, right? So you got to have something with a little bit more responsiveness to it.
Yeah, exactly. And that's where things like that, obstacle avoidance, you're not waiting on a Raspberry Pi to tell you, hey, there's something in your way. It's being done on a microcontroller, which is going to be whatever, within a 20 or 50 millisecond loop, whatever you're running, and it'll know right away that, hey, there's something there.
Well, distance monitoring is a different animal too, besides just real time. Like the sonar sensors, right? Especially like, what is it, the SF04s, they're really slow because you have to wait for that sound to bounce and come back. So It's not really about real time, but it's just about the responsiveness of the system. But to your point, the real time part comes in that, you're talking about a few microseconds difference between several inches, right? So your resolution then becomes more critical.
Yes.
But it's a lot more difficult to do on any kind of, I wouldn't say interpreted system, but any kind of system with a heavy OS, even like an embedded Linux platform.
And that's what I was finding on a Raspberry Pi, that I was, 40 plus 80 milliseconds, let's say, before I received data, and it was out of date.
Yeah.
And where it became tough was, you're trying to follow a line, follow a path, and you're all over the place with it. Not to mention a compass, which is a whole nightmare by itself.
I think GPIO in general, unless you use the mapped IO through Linux, is traditionally very slow and non-deterministic, right? I mean, if you want to create a 50 millisecond pulse on a pin, good luck. It may be 60 one time, it may be 45 another, you just never know.
That's where it's so nice on a microcontroller is that
Yeah.
you're very, very close to that 40 milliseconds, 40.0001 or whatever it's going to be. It's pretty accurate.
Mhm.
It better be, spot on.
Exactly. That's what you're hoping for, and that's what you get. So when you run a loop and you're reading sensors and you're processing your loop, you've got your latest data.
So my old box of Arduino 8-bit systems may not have to go in the garbage after all.
Right.
Well, I think it's more about how you get that data transmitted, right? I mean, I don't know what your methodology is, Pat, for, so you have an embedded system doing some, heavy lifting as far as real time goes, but you still got to escalate that data up to the main system, right? You got to consume that data somehow.
Yeah, but it's right now it's what I'm looking at doing is, so like my AI camera detecting traffic cones, for instance, well, it's going to feed the data down into the microcontroller. So if it's going to every 10 times a second or 20 times a second, it's going to pump its information down to the microcontroller. And the microcontroller will handle that in some sort of subsumption fashion and take it into account and determine who's loop am I processing. And guess what? I don't care because I'm way too far from the cone. So ignore the GPS for now, or ignore not the GPS, but the AI camera, that sort of thing. So when I get within 30 feet or 50 feet, start looking for a cone. I'm within the radius, start looking for data is the plan, and not be spinning around in circles with trying to rely on a compass for directions and stuff like that.
Yeah, you need to narrow that down, because what kind of camera are you using?
I'm using
recognition.
MEIX Max Bit. I forget which one. It's got an AI built into it.
Oh, okay.
Oh, the Max Cam, that one.
The Max Cam. That's it.
Yeah.
Yeah. 50 feet may be a little bit long on the expectation, though, in my opinion.
I was
You
spotting.
should probably bring that in a little bit to be more consistent.
Well, the GPS by itself without RTK, I'm good to, let's say, 30 feet. Typical on the far side, 30 feet out from where I am, which is close enough to detect a cone.
Well, but like I was saying earlier, it's also about mapping the data, right? And I think that's where my issue has come in in years past, where it's like, I know that cone is here somewhere, and the robot just, it'll find two cones just fine. And then the third one is like, I don't have a clue where this thing's at. And I've kind of thought, well, that could be to where did I map it at? And, I think some of it too is there's a lot of disturbances up there, because that's where everybody parks. So there's a lot of metal cars, and
if you're finishing
there's some speculation to be said that could affect, what you're seeing. So the fact that your robot can get within, 4 or 5 meters is one thing. But if your data point is another 2 or 3 meters off from that, then, your error starts to collect. So, I think it's, like I said, I think it's as important as accuracy as being able to map it accurately. And I know, like in years past, we've kind of passed around numbers and kind of, compared them. And everybody has a different number, but it's really hard to say, well, if I increase this number, does that move the point north or south, or,
that's where it would be nice if
smarter than me could do that, but that's outside of my limits. So you kind of, like last year, I kind of averaged between mine and Doug's and Paul's, and the first run is like I wasn't even close, and then I kind of went back to the numbers that I had originally recorded. But one of the things that I also read about in all the uBlot application notes that I went through, was they talk about mapping it with the same antenna that you're using for the rover,
Yes.
right? Which is, I've been using a completely different radio. So that's why I had ordered another one. You know, I bit the bullet and ordered another one of the F9 modules, so that I have the same radio that I can map it with. And then I'm going to actually use this radio and I'm going to plug it into Turd, because it's where the radio is in Belch is actually up under this interface board. So pulling it out to map, you know, would have been a real burden. So I figured I could kill two birds with one stone, and upgrade Turd as well as Belch with RTK. And then I would have something more available that I could pull off and map my positions. So that's my plan. We'll see how it works out.
Well, I'm curious because I know people have been getting good results with them. I'm still not there. I'm not ready to spend my hard-earned money on RTK GPS. So I will deal with the 30 feet accuracy or 10-meter accuracy for now. And if I can get within the circle and get a point, I'm going to start.
You got to start somewhere, right?
Exactly. You start with one. Well, you start with going in the right direction.
Well, that's true.
If you get 1 point, you know, hey, that's a win. It's an improvement.
Well, and that's the same way I kind of felt when I saw, you know, the performance of Paul's robot last year. It's like, that's impressive that he was able to do that just straight off of RTK and GPS guidance. So it's like, okay.
I would,
because it also kind of negates the limits that I have with the Pixie Cam, right? Because when you're trying to find the cone, it's all a matter of the shading and the light and what it's set up to find. And sometimes you can be right next to the cone and not have a clue it's there. And sometimes it can be 30 feet away and say, oh, I got you. You know, I'm after you now. And it's just so unreliable, you know, and a lot of that is just environmental conditions, you know, the way the light's hitting it, how you programmed it. So, you know, if you can eliminate that by being a lot more accurate to where should the cone be, right? Because normally when you're right up next to the cone, the Pixie Cam does fine. It's like, oh, there's a cone right in front of me. Look at that. You know, I had no clue till I got right here.
yeah, I could find a fine on my desk. It's in the real world that it becomes an issue, in sunlight, in shade, in, you know, everywhere.
When I saw the 0.06 meter of resolution, I was like, okay, that's me. That's got Belch written all over it right there.
So is that 6 centimeters?
The 0.06 is 60 centimeters.
No,
right?
that's 6 millimeters.
Or 0.06.
That's like a quarter of an inch.
Is it 0.06 meters or 0.06 centimeters?
0.06 meters.
So
yeah,
60 millimeters.
Okay,
6 centimeters, yeah.
Centimeters, okay.
So 6 centimeters, which is whatever, 2.5 inches or approximate.
Yeah. I can probably,
Right.
my
Yeah.
Pixie Cam can probably find a cone within that range.
Yep.
Not if you keep circling it.
Yeah, no, I guess not if it's right beside you.
Yeah. Oh, I felt bad for you last year when you make it all the way back home and you miss the cone, and that's tough. There goes the
brother.
Yep.
And I mean, and Carl didn't even have his shoelaces this year. Right?
Oh.
Wasn't that last year?
Orange shoelaces last year?
Yeah.
Okay. I know there was.
It's been that damn last cone the last couple of years that just screwed me up. So
One year, I think the 6-can competition, somebody had a pair of orange shorts or something on as well.
no, and that was Paul Boucher with an orange T-shirt.
Orange T-shirt. Okay.
And then a couple of years before that, it was Ray with his orange poster board.
Okay.
Yep.
And then there had to be an adjustment of the rules just for Ray.
Well, yeah, it was an easy fix. I mean, you the cards,
use
the
the
center
green
of
one
the
next time.
pixels or the big orange poster boards was a lot higher than what the vertical
well, I
height
mean,
or the average would be for a can.
And I still have that test in my robot code now that it has to be, within the lower portion of the frame.
Yeah.
Right. Because I mean, the can's not going to be,
Yeah.
up on a pedestal, right?
Yep.
It's going to be down on the floor. So,
Yep.
Yeah, I still have that actually I have that in belts too, because of
Yeah.
that red building in the back of Steve's yard. Yeah, because my robot went after that. It's like a metal shed building.
Oh yeah. Yeah.
It's actually red like a barn,
Mhm.
but in the right sun and the shade, man, my robot just kept going after it. I think it was the first year we had it out at Steve's. But so yeah, I even put it in there.
I had the same problem with leaves and brown.
Yeah,
Here.
I bet.
And they get a bright browny orange color, and it sees it as orange, and
That's why the blob color recognition just isn't really the consistent way to go about detecting a cone, right?
and if you get the right couple of weeks up here, the brush is bright orange. So
Well, like
I took pictures a few years ago.
The Robo Columbus used to be like later in the summer, like in August, early September. So the shadows were much higher. And then when we started having it in October and November, then the shadows get much lower. So it created a whole different problem set for the color blob, the blob recognition. Now the changing of the leaves would definitely be a huge issue. We don't really have a lot of that here. It goes from green to brown in pretty much a hurry.
It'll last a couple of weeks here where the brush, the willow, everything else turns reddish to orange, and it's all low to the ground. So it's in the area that you're looking for it, and depending where you're running your course, it can be quite a challenge. So that's why the AI camera at least will detect that, hey, that's not a traffic cone, that's just something.
Yeah.
But it's not perfect either, because it picks up my orange pop can as a traffic cone. So I didn't put any orange pop cans to exclude it I'm not too worried about that.
Yeah, there was it was a color sensor that Adafruit made, really cheap. And 3D printed like a little, tube to mount the thing in the back and put a small lens in the front. And in the springtime when the grass is green, it could easily find a cone. But here, when the grass starts to brown out because of so much sun and no rain, everything looked yellowish orange, and it just couldn't find the cone for its life. So it's like, if we have the contest in the spring, this is a great sensor, but otherwise,
Maybe the two contests should be reversed, and the Robo Columbus should be in the spring when everything is green, by the end of May, and then the fall do an indoor competition in November.
When you got colder weather and all that stuff.
That's our problem here, is that anytime after October we could have snow permanently underground.
Oh, that should be easy to find a cone.
Yes, but now I have to put tracks on the robot to go through the snow.
Get through the snow.
We used to have 2 indoor contests a year. I'm not sure why we just been having one here lately, but I think it was pre-pandemic, wasn't it, Ray? There we'd have 2 indoor because we'd have can soccer, and then we'd have 6-can.
But yeah, that's true.
They would be in different, competitions. One was in the spring and one was in the fall.
Yep.
And then that's why we had Robo Columbus kind of in between them for a couple of years.
The year I started up with you guys, you had a Robo Columbus in August, and I remember you guys baking.
Yeah.
At Steve's place, and they were saying 100 and some degrees there.
That's how hot it gets here. Yeah.
Yeah. If we get to 100F, that's hot for us.
Well, we've been lucky this year. We've only had like 300-degree days in the Dallas, officially in the Dallas-Fort Worth area.
Yeah, that's amazing. Yeah.
And it's been really nice the last couple of days here. I mean, for August, for us to be in the low 90s. It was in the low 90s Sunday and yesterday. So yeah, it's been a nice break. What we usually by this time of year, we've had, at least 100-degree days.
Oh, wow.
Mm-hmm.
It's about 80 degrees here today, so it wasn't around 25 Celsius or so.
Mm-hmm.
Okay, well, any other questions for Scott? Next up, we got Mike.
Like me. So I'm going to try this, my GPS sensor right here. It's the SAM M10. So uBlocks 2 is supposed to works pretty good with it. And last year I got it running with Ross and was able to show that the GPS works, drove the robot around and saved the information and plotted it out. So I know I can get this darn thing to work, but it still has the standard GPS settings, or accuracy. So I'm hoping to get 3, 4, 5 meter resolution.
So is that one of the Chinese M10s or an actual?
It's a blocks.
Oh, it is a U-block.
uBlocks, yeah.
Yeah. Okay. Well, Tom, I thought you said even the counterfeit modules said they were U-blocks, didn't they? Yeah.
Yes, they often will be differentiated because that nice printed label is either mounted not on the center of the antenna module, or it's got incorrect coloring or poor definition of the text. So those are the clues. That one looks pretty good, but it's hard to tell in this camera picture.
Yeah. If I put a magnifying glass on it, it's pretty sharp. Yeah. Yeah.
Chances are, if you bought it locally from a reliable distributor, then you probably got the real thing.
Yeah, I did. Yeah.
You guys aren't buying from China anymore, I don't think.
Well, this was bought last year, so I'm sure it's double the price now or something. Just the components.
I just got a bunch of stuff at AliExpress. There's like a small additional fee, but it's not, like, I don't know. I think it's way less than 10%. So I don't know if the tariffs didn't apply to, things that are priced under mostly $10 or something, but
I think they're just implementing. They had an $800 under $800 didn't get taxed in the US, but I believe they're just changed the law and that's going to go away.
Yeah, I heard that.
I think they closed that loophole.
So they closed it. The other thing is people do receive notices in the mail later. Oh, by the way, here's what you owe.
Oh, really?
Oh, but the consumer doesn't pay the tariffs. Come on.
Keep telling yourself that.
Yeah. So
I know we bought a bunch of stuff for commercial.
Back to us for tariffs. It's like, by the way, that stuff we built for you, you owe us another, whatever in tariffs for it.
Yeah, exactly. I used a customs broker. I bought $45,000 worth of equipment out of Washington, out west, and we used a customs broker to make sure that we had our bases covered. So basically, when we received the material, our customs bill was paid, everything was done, and it was well worth it for, let's say it cost us $500, $700 or whatever for the customs broker, to have that headache come and gone. So we'd allowed 25%, and I think we got hit with 5.
Yeah, good. Yeah.
So.
Yeah. Well, I'm going to be my car for the Robo Columbus is a Ackerman, like a steering car, and my brain's been going, boy, even if the GPS gets me close, how do I pan the camera around to find what I'm looking at? So there's going to be a complex little juggle or something going on. Because if it's a differential drive robot, you just sort of shift the wheels and you can do it.
Mounted on the servo?
I found, because Turd is the same problem I have with Turd, right? What I do, the way I approached it was I'll actually back up because you have a much tighter turning radius when you're backing up. So I can kind of back up and scan, to one side. And then I think I drive forward some to kind of look in the other side. So I kind of do a pan. So I'm sitting here facing one way, and then I back up, and then that gets me this side. And then I drive around like this, and I kind of, and as I'm sweeping around, that kind of gets the other side. Because you're right, like here with belts, I just pivot right in place, and you can't do that.
Right.
I do the same kind of approach. Like after I've hit the cone, right, I'll turn the steering maximum, and then I'll back away from it. And I just do that for a certain number of counts, time based. And then I turn the wheels hard the other way, and I take off. And then I let my guidance say, okay, which direction do I need to be going?
Yeah.
Because that keeps me from running back over the cone.
That's a good thing. Yeah. Yeah. So it looks like I got a lot of dancing movements to
it's
choreography. Yeah.
It's definitely more challenging than just differential steering, because there's more steps involved, right? I mean, whatever you're using, a state machine or, process stack or whatever, it's got more steps in it now. And so, how do you transition from one step to the other? And there's more to it than you really think. Once you start breaking it down into all the individual pieces of what you need to do, it's definitely more challenging. I'll give you that.
I wonder if it'd be simpler just to stick the camera on a servo and pan around.
I mean, you could do that too. I mean, that would be, but to me, the challenge there is, okay, lining up the servo to the platform of the robot, right? Because ultimately you still got to be pointed at the cone to touch it, right? To really be able to touch it with any kind of grace.
Yeah. So I've been working on my how to control the motor. Boy, it's a real pain, but I think I've closed the PID loop, but unfortunately it's a long time constant because of long delays in the motor. I give it a command and it takes a long time for it to respond. But you can see, and this, like the red dots here are the encoder, is the information from the encoder in terms of meters per second, converted to meters per second. And the blue lines is my step, this is basically what I want to go to is this meters per second right here. And the orange one is what I'm actually sending to the ESC. So you can see that it's flattening out. But one of the issues that I'm having is when I go to 0, there's a what do you call it, a dead band of some sort. I mean, a dead band that's documented, and I measured it at 10% of the full throttle. But you can see here that it comes down, and then the red dots, which is the encoder, basically says, "Hey, the wheels have stopped," and then the PID loop stops here. It says, "Oh, I don't have to work anymore." So I'm having a hard time going really slow. Like this is 0.1 meters per second, and it works pretty. It's working pretty good. But when I'm slowing down, it sort of stutters when it gets into this deadband region here.
Mike,
So-
what is the full speed of your motors?
I don't know.
I just wondered
I mean,
whether.
I think I can go to 2 meters per second, easy.
Okay.
So I'm not
What's
sure what
the-
the RPM of the motor is, but the movement of the car is like 2 meters per second. I think I can push it higher than that because I'm still in low gear,
So,
but I don't think I can control anything any faster.
so you're trying to provide PID control down at very, very low proportions of your total speed band.
Yeah, yeah.
All right, that's hard. When I get to there with the ones I've built, when I get really close to zero, I just go to zero.
Uh-huh.
That's just
Yeah,
good.
I have a deadband as well, so I have a minimum threshold to actually declare any kind of H-bridge activity, if you will.
Yep, same thing.
But what's the resolution of your encoder? Because at lower speeds, you're going to get, especially on a much coarser encoder, you're not going to get. There's not a lot of data to work with, and especially if it gets too coarse and your PID loop is actually running faster than your encoder update, then there is no PID going there, right? You're just
I'm
you're behind.
getting
You're
a
too
lot
far
of dots
behind.
down here because
So
my encoder puts out 6,000 pulses per meter of travel. So even at less than 0.1 meters per second, I still get quite a few for each of my sample periods. My sample period, I've decided for my whole machine is 30 hertz. So it's 30 milliseconds. And I get like at the very, very low end, that gets down here, gets to be about 6 or so samples coming out of the encoder. So you can see here that it is coming down and working the way it's supposed to work. And the width of the noise is pretty much the same no matter what the speed I run. One thing I did do is I had higher noise, and so I had to filter it before I put it into my PID filter. And filtering it is well, you don't want to slow it down too much. So I used a median 3 filter. If anyone's used a median 3 filter before, but it's basically you take the last 3 samples and then you find the one in the middle and then use that sample. So it gets rid of lots of big extremes and just keeps like a simple one. And the worst case you have is one sample delay. So it works pretty good.
How are you scaling it? Are you using it directly by count, or are you averaging it and taking the ratio? Because when you get to, and here's why I asked that, because when you get to really low counts, like what you're talking about,
Mhm.
The difference between 4 counts and 6 counts is, 20%, right? So if you were to say, okay, I have an average maximum count of 1,000, let's say, right? And my current count, and just to make the math easy, is 500, right? I'm at 50%. Okay. And of course you have to do floating point here. So when you get into lower ranges, right, your actual input data is much coarser than what your output is, right? So you kind of have this built-in filter that you're not, especially again at lower ranges, you don't have such a dramatic change in your feedback, because now you're just a little bit more in the percentage area. Because if you think about an extreme case, 1 count versus 2 is double the feedback, right? But you're not going twice as fast at 1 count as you are at 2.
Right. Yeah.
Right. So
So you can see that it's working really good down to about its cutoff range here.
but to continue the example, the percentage ratio of 1 to 2 in a scale of 0 to 1,000 is very, very small, right? And that's really the change that you're seeing is a very small change. But when you're reacting to it by count, then that's twice the count that you're having to react to.
Mm-hmm.
If you follow my logic. So if you take it and divide it, whatever the current sample is by the maximum, now you get a ratio of what where on the scale am I, right? And so then you can even feed that back into your PID loop. Like if your PWM now is 4K, right? Like a lot of PWMs would be 0 to 4,000. And that's how you scale things from one domain to another, right? If you have, 0 to 1,000 input, but the PID you're controlling is 0 to 4,000, right? You can always take a ratio. So if I have 50% of input, then I want 50% of output. That number is not going to be the same, right? So it's kind of the same thing. And the other technique you can use at lower speeds is kind of to interpolate it, and basically you assume data. So you kind of fill in gaps where the steps are. But doing an average or a percentage of your scale is going to help you tremendously, especially like in the PID. I mean, that's how I set up my PIDs is everything's a ratio. I don't take a raw count from anything, because that way I can translate from, like I said, one scale to another very, very easily.
Mm-hmm. Mike, the other thing that I've done with H-bridge driven motors like this is to produce a reference input, pulse width modulation reference input to speed curve. That's why I was asking you how fast your motors go, because that would be the 100% pulse width modulation point is the top speed of your motor. Your graph suggests that you're attempting to do fairly good control down at a very, very tiny proportion of your top speed, which is therefore some very tiny proportion of the pulse width modulation zone. It also gets into the problem of what the gear train system is doing with variations in resistance, in friction, which causes it to need more or less power to move a very small amount. So if we were to attempt to do the pulse width modulation width to speed curve for your typical gear motor, down at the very low speed levels, you'd probably find that it's incredibly difficult to provide a reference to give you an accurate speed down there, which will also cause your PID loop to be oscillating all over the place. And then you drive it with, as Scott pointed out, highly variable, uncertain input data to begin with. You're going to produce a lot of problems. You're far better off to try not to work down at that extremely low speed point. Learn to live with 0.1, learn to live with 1% of your 100% speed point in terms of your pragmatic movement of the robot, because you can control down to 1% relatively easily. You're already showing that here. But if you can control much below that, you're running into these incredible noise and friction problems.
Right. Yeah.
So doing it.
Okay. So my system, it's a brushless motor FOC ESC controller.
Okay.
And it has a serial port interface and with lots of bits. In fact, I can get down to like 0.2% control is what I measured.
Okay.
So
what percent or what kind of sensors do you have in your motor? Because you can get encoder feedback ones, you can get Hall effect ones, and I think the sensor, the feedback from the motor, the telemetry of it wasn't good. I mean, the information it gave me was just too rough
and too slow. And so I put a shaft in, I put a rotation encoder on the shaft. And so it gives, like I said, it gives me 6,000 counts for every meter that the robot runs.
But if this is like a 3-phase ESC AC motor, is that correct?
DC, I guess.
Well, I mean, how many wires is there going to the motor?
Oh, 3. There's 3.
Yeah. And
So
it's a three-phase
it's
brushes.
an AC motor then, and unless you have, and I'm taking some guesses here, the encoder you have is just giving you position feedback. Is that correct?
It's just giving me rotation, like, the speed.
Right, but you send.
It gives
what
me
kind
like
of
the
command do you
encoder.
send to the motor control to drive it. What kind of signal do you send to the motor controller, the ESC?
Oh, it wants a percent of full throttle, but down to like 0.02% or something. Yeah.
Like a servo type of input or output? Like
It just gives
like an RC
Yeah, it
transmitter
just-
would have. I guess what I'm driving.
no, it's not that. It's a serial interface. It's a packet.
Oh, okay.
So you send it 10 bits or 12 bits or something like that?
I think 12 or 14.
12 bits, that makes sense, yeah.
Where I was going though, if that encoder feedback isn't being driven into the motor control.
Oh,
Right.
well, the censored motor controller is the sensor of the motor speed is plugged into the speed controller. That's just a black box to me.
Right.
Does the speed control, the FOC control, does it not have sensors, 3 sensors going?
It has sensors, but it's a little.
Could you not use those
But
as
it's still somewhat sensitive to voltage. Like you can see right here that my signal is higher than the average of my like the signal I'm given to it and scale to meters per second is higher than where I wanted to go. And as the battery runs down, then this moves a little, changes, and the idea is to run at the same speed. Like the motor controller, the ESC controller, it's a pretty good job, but not great. And it takes a lot of it's just slow. And I wanted a little more precision. Like if I say go 1 meter, I want it to go 1 meter within a centimeter or so. Yeah.
What I'm driving towards though is that resolution and position doesn't feed into your motor control system.
It doesn't directly.
Something
It
built in,
feeds in through my PID. That I have my loop in my microcontroller.
Okay.
And it sends a signal to the ESC to say, hey, go at this speed, or go at this. Like I can't give it a speed input. I can give it a percent full throttle. So go at this throttle and I adjust the throttle until I get the right, but up here, I get the right speed. Yeah. So it's been a journey, and I'm trying to figure out how to make this a little better down here, so it doesn't. So when I'm running, like when I get to a cone, I want to just get slowly and kiss it. I don't want to knock it over. So I can't go too fast, and even if it's a little jerky because of the noise, it's still. I think I can still do it.
Doug will take points off if you knock the tennis ball off,
Oh, I know. You can't. So basically, I think I can run pretty slow and get close to the cone and kiss it without knocking the tennis ball off. I've been watching my car wheels, and it's like, at the slow motion, they go slow, but they sort of oscillate because, like you said down here, it just sort of wiggles, but it doesn't go crazy. It just moves, a centimeter or so of noise. But
so Mike, what if you at very low speeds you just fed it a constant output on your throttle? So you'd give it a whatever your pulse width modulation signal you're sending, like a servo signal or whatever you're sending to your feed. Instead of doing a PID at low speeds, just send it a constant voltage output to the motors.
Yeah, because you don't have, you're not trying to go a meter. Yeah, you just want to go slow. You don't care what speed it is. You just want to go slow. That's what you're saying. You
pick a slow speed that's going to work, and you just set it to slow speed, constant output, and see how that works.
Yeah, that's interesting. Yeah,
because that may give you smoother action at a lower speed.
Right. Like according to this, once I get below 0.02 or so meters per second, just go to a an open loop mode.
Yeah, go to open loop mode and see how that works.
Yeah.
Because ultimately, too, Mike, you're talking about positioning, not speed control, right? You want to position the robot in a particular space.
Right. So I can use these encoders.
You don't care how fast or how slow it takes to get there, right? You just want to know that you're at the position that you wanted it to go to.
Right. So I can basically say, okay, it's close. Now let's use this. Well, I'll take these encoder values, and I know exactly how within a few millimeters of how far I've been moving, and so I can.
You'll find that there's a lot of variance there, especially on an outdoor course. When you flip traction, or especially like in Steve's yard where you bounce around a lot.
At these high speeds, yeah.
Even at low speeds, and it doesn't take a lot to really kind of, because that was the approach I originally took, because I was thinking that GPS was just too slow. The update rates was just too slow to actually navigate straight off of GPS. So I calculated, Cartesian grid. I want to go to XY, and I used my encoders to try to get there. And it's not a road you want to go down. It's not a good road. We see enough of that indoor on a solid surface, right? And you've probably experienced it. You see it with the can or 6-can. The error as you turn and move and navigate, the error starts to collect, and after a while it just gets too big. And it's even that error is much greater outdoors, especially in a yard like Steve's. His yard is not real conducive to robots.
Yeah. So I'm thinking, this gets me within pretty close to the cone. Of course, then you turn the camera on and you go, oh, let's get closer. And then you use the time of flight sensors when you're, half a meter away, and then you slowly pull in with that. And that's basically where you go to this low speed mode, just go at a low without an open loop mode, so you're not causing a lot of noise from the PID loop. Yeah. So I was going to show another thing that I just got something today. So try to find, where's that other screen I'm looking for? This one. Okay, so I guess I'm doing the feedback here and go to this page here. So do you see a page? Are you seeing a nice clean page?
Yeah.
Yes.
Yeah, programming.
Yeah. So I got a programmer, a programmer for my ESC controller, because I noticed that there's a couple things that can make it better. Basically, one of the things is the neutral range, which is the dead zone. I read this and said defaults to 10%. I goes, oh, that's what I measured, 10%. That's great. Well, I can about half it to 6%. So so I can get a little better low speed control of it, assuming the noise off. And then another thing is something called this start mode, the punch. So I'm thinking that if I push this up a bit, I can get a faster response time through the motor controller, and which is part of my PID loop. And so I should be able to run my PID loop with a higher bandwidth. And so the drag, the break rate, I'm not sure exactly what it does. So and so you go down here and it says what all the different things you're supposed to do, like the power and the reverse power. And so basically I'll be able to tweak the ESC controller a little bit with the programmer that I got. And it just arrived today, and I'm sort of anxious about putting it on there and screwing it up. So there's a couple things I can do to make it better, like reduce the deadband and make it a lot more responsive, so that it follows my speed control faster. It's hopefully it'll lower the delay. I'll find out if it works, because the PID loop is going to slow it down a lot anyway. So I think it should work. I'm going to close this, stop sharing. So and then today I got it working. I got the PID loop working pretty good and the interface working pretty good, and I connected it to ROS and got a module running it, and so it's the ROS was controlling it, setting the right mode and the right speed and that kind of stuff. It's up on the bench, not on the ground. That thing's so big and heavy and powerful. I'm not going to put it on the ground until it behaves really well on the bench. And so I did that, and then if you know about ROS, there's like teleop. So I got a thing to respond to teleop keyboard, and then I was trying to get the teleop joystick running so that I could use the controller here, which I think I could control it a little better than a keyboard. And it ran out of time, so no demo. That's mine. Thanks for all the feedback.
Thanks, Mike. Good update. Glad to hear you're making progress.
Thank you.
I know I'm not making nearly enough, but
I'm not either. Yeah.
good job. Next up, we have Tom.
This one way. It's been several weeks since I've been here. I believe that I probably showed you the old security camera compared to the new security camera image after I got my first one. So I've made much more progress since then. Let's just share this. Okay, you can see that. You can see my mouse moving.
Mm-hmm. Yes.
Okay, so this was an image I took a month or so ago from the old camera systems, which were standard definition analog video. They've been out in the Canadian weather for 11 or 12 years. So they've degraded a little bit from their original capability. So I decided I was going to upgrade them all to high definition cameras. So this is the high definition camera that I picked. I mounted this first test camera right on top of the old analog camera in the backyard, pointed in exactly the same direction, and took these two snapshots at exactly the same time. So this shows you we've got a much, much better image. I'm quite happy with it. It's a little wider field of view as well. So I proceeded to buy enough cameras to replace everything, and I installed all of the wiring. These cameras are implemented with power over Ethernet, instead of separate analog and power wiring. I'm not a fan of Wi-Fi for outdoor cameras, so they're all wired PoE. And then hooked it up to public domain software called Zone Master, which I've used before and found very, very capable. And it continues to get even more capable. So this simply shows the 4 cameras in a montage image in a ZoneMinder browser view. I'm running ZoneMinder on a Ubuntu server. The Ubuntu server is 2 CPUs, 4 threads, 16 gig of memory. And at this point, it's pretty much coasting, even though I've got 4 high definition, 4 megapixel camera signals here. And that's what is being processed for motion detection. That's not recommended, but that's what the default is for ZoneMinder. So I haven't changed that yet. This is pretty much coasting. I'm pretty happy with the way it's working.
So the Zone Finder runs the detection, not software in the camera?
Correct. And you've raised a good point, because these cameras are extremely capable cameras, even though I only paid $25 Canadian for them. They're astonishingly cheap. They do a very, very good job, and they have a full Linux computer built into each one of them, including object detection and motion detection and a whole bunch of other things, most of which I'm not using. I'll configure all this stuff inside ZoneMinder. I do have one point to make about the camera. This is one of the configuration web pages taken from the camera's Linux box in its one of its configuration modes. There's a ton of web pages that it's capable of showing, which are used to set up a wide variety of configurations. This is the image setup, the image setting page, and I've been working on over the last week or so in this advanced configuration mode, because once I started to pay attention to what was happening in ZoneMinder at different times of day, it became clear that the automatic exposure control was not working properly. And after a bunch of fiddling around, I found out that if you have the anti-flicker enabled in this particular firmware implementation, then that messes up the auto exposure control. Now, I turned on the auto flicker simply because it's a good idea if you have flicker. Well, I don't have flicker, so I was able to turn it off, and then the auto exposure control ran again. I suppose one of the limitations of a $25 camera is they don't do perhaps the best software debugging that they should do. Other than that, these things are working very, very well. I'm quite impressed with them. I've been doing some work to do things like this particular picture shows my carport, which is in shadow, and it shows bright light at the foot of the driveway, in which case you can't see anything at the end of the driveway. There are configuration modes here, which when you turn them on, straightens that out beautifully. And you can then not only see what the carport looks like, but it also regionally modifies the sensitivity of the image down here in the whited out areas. And all of a sudden you can see it all again. So they're very, very capable video processing logic built into this thing. I'm not planning to use the human object detection that's built into the camera because there's quite a bit of it built into the ZoneMinder, this current release of ZoneMinder. And I intend to start to play around with that once I've finished a bit of fine tuning with the basic motion detection. I'm looking forward to that. The downside, of course, is when you start to run a bunch of machine learning algorithms on top of motion detection, then you can end up with a lot of heavy compute load. Right now, my CPU is coasting. I'll be very interested to see what happens when I begin to play with the various modes of object detection that are now available for ZoneMinder. It should be fun. I've also ordered some more cameras.
So are you overclocking the computer?
Nope.
Not yet. Okay.
And in fact, if I start to run into trouble, but see, being a really cheap guy, when I needed a computer to run this server on, I went to my large collection of cast-off desktops and sorted through them until I found this one that was suitable, which is probably 10 or 12 years old. So if I really wanted to go faster, I would probably spend a little bit of money on a search.
Yeah.
Or ask somebody for a newer cast off.
Mhm.
There's lots of them out there. This stuff runs really well at night. For instance, here's a fox coming down into my backyard. As my daughter says, we don't have to guess what kind of animal it is anymore. This one was for a friend of mine in Vancouver. This night there were 4 raccoons digging in my backyard. There's a 4th down in the bottom left. They're looking for stuff to eat in my grass. They were very busy doing this. I have a friend in Vancouver who I showed this to this past weekend. He has a koi pond, a goldfish pond in his yard in downtown Vancouver. And the raccoons love it, of course, because that's a free meal to a raccoon. So for the past several years, he's been working at experimenting with using electric fence components to build a guard around his koi pond to keep the raccoons out of it. That's been fun. Anyway, any questions on any of this stuff?
So how high does a raccoon jump when he hits the 6,000 volt?
He says he did for a while have a camera on him just to find that out. He says he really didn't want to kill any of them.
Whoa.
And he says they actually have learned to avoid the koi pond because of the shock that they get. The problem is that in the course of learning, they tend to disturb his electric fence assembly, which is it's surface mounted on a brick ledge that goes around the pond. So he says they tend to move it around a lot in the course of getting shocked. So he's continually having to make it more firm so it won't move. He has killed a few mice and he's killed a few smaller birds who happen to get in the way. But he's not worried about them. He just didn't want to kill any raccoons.
So does he have any video of the raccoons getting shocked?
I should ask him that. I don't know. He hasn't mentioned it. I showed them the same stuff on Sunday we have a regular Vancouver and Ottawa meeting on Sundays, which is supposed to be robots, but isn't always. I showed them this stuff then. I was astonished at the amount of interest in ZoneMinder and these high definition cameras. So I believe Paul in Vancouver is going to get some more cameras. So we may see some. These are surprisingly good cameras for the money. That's $25 Canadian, no shipping, 7-day delivery out of China from AliExpress. It's really impressive. And they're working fine so far. They've been out there a month. Yes, that's it. I'll shut this down. Anyway, that's just a simple update. Nothing as interesting as what you guys are talking about robot-wise.
Well, thanks, Tom. That was interesting. Some cool video shots of the raccoons and the fox. Next up, we got Ray.
Okay. Well, mine's pretty simple. It's like not really related to robots that much. I'm trying to get, I think I have this up on screen. Let's see here.
Tom, Ed is asking if you could put a link for the camera products. If you have an AliExpress.
I will. Just
share that. Anyway, okay. Oh darn! I gotta scroll it on the page.
$5, but we don't know what for.
Darn it! Yeah.
EESBAO. That's what it's for.
Yeah, I didn't realize I had to get exactly on the page to. There it is. Okay. Yeah. Okay.
Oh, solar controller. Wow.
Yep. Yeah. So these are, I have, 2 gate openers, and I was previously just had one, and I actually ran an AC line out to it, low voltage, about, 20 volts AC, and that would keep the battery charged, but the whole thing got hit by lightning and got destroyed. So I was thinking about going, trying the solar approach. So these are maximum power point tracking solar chargers, and basically what it tries to do is get the most power out of the solar panel. And so that's not at, the highest voltage or the highest current, but at some point, on its output curve that produces the maximum amount of power. So the voltage will be lower than the open circuit voltage, and the current will be, lower than the short circuit current. But anyway, the size batteries that they recommend to, there's like that you can actually put in the enclosure. They're like, I think, pretty much lead acid, but I think they're like gel cells, or I forget what that's called. Anyway, you can mount them in any orientation; they won't leak. Anyway, so the Mighty Mule, who makes the gate opener, they recommended like a 15-watt panel in our area. That's based on how much incoming solar radiation there is per square meter. The best that gets like is out in the desert. You can actually get above 1,000 watts per square meter, and the solar cells aren't super efficient, so only a percentage of that gets converted. And out here in Texas, we're close to the eastern part, and there's a lot more moisture in the air, so even less solar radiation gets in. So anyway, I had a 6-watt panel, 2 7-watt panels, and a 10-watt panel, and I tried one of the 7s and one of the 10s, and they don't produce quite enough power to get the voltage out, or up to what you'd like to fully charge a lead acid to, which as far as I can tell is like 14.4 volts. And so a nominal would be like 13.8 when it's just floating and not being charged. So these will get up to like only 13.4. And the other weird thing about solar panels is the hotter they get, the less they put out. So if you actually put out more, early spring, fall, when it's cooler out, but you're still getting, fairly good, solar radiation coming in, or intensity. So, but in the heat of the day, it only gets up to like 13.3, 13.4 volts. And that's not quite enough. So I'm going to have to get a bigger panel, which has a higher maximum power point that, this thing is supposed to load the cell down, the solar cells, to produce that amount of power. But anyway, so it's been kind of a neat experience. I had on my solar array, I actually have 39 panels. They're 3 strings of 13. And I have a string converter, which I don't think people are using string converters that much anymore. But this is kind of another version of that, for that 40th panel, which fits on the thing, on the array. I was going to use this one, and one panel to do just battery charging in my metal building. So I was going to run the voltage off one of the panels to this. And this is also a maximum power point tracker, but it'll handle, those solar panels are rated at 230 watts, and this will handle the higher power, whereas these smaller ones will not.
Mm-hmm.
So anyway,
Yeah.
So I guess the other thing I can try, I'm not certain how well that's going to work, but I can parallel 2 of the panels, to the 7-watt panels, to try to get it to 14. But the panels have to be pretty closely matched, if you just parallel them together. Otherwise, one will produce a lot more, output than the other one will if they're not that balanced.
Mhm.
And so that's what I've been working on, just kind of experimenting, putting the panels out in the sun, hooking them up to the battery and the solar charger, and just seeing what they'll do. And I've had these solar panels for a long time, so it was just something I had and I thought I could use, and turns out nope, can't use it the way they are. Anyway.
Yes, I built a solar thing for some lights, and the objective was to have the batteries be able to run it for 3 days, because when it's overcast and raining for 3 days, you still want your lights to be on. You still want your garage door, your opener to work.
Yeah.
And it works pretty good. One thing I found out was the batteries, the gel cell lead acid batteries wear out pretty fast when you charge them and discharge them. And it sort of, and the quality of the battery is really important. The cheap ones don't last long at all. And so basically they run for 2 or 3 years, and then it's like, what's wrong? Oh, the battery. So you replace the battery. And if I was ever going to do the system over again, I'd probably use lithium, which you could run it for 10 years.
Oh yeah, several days. Yeah, would you go with lithium iron phosphate though? Because they're supposed to be safer than
yeah.
particular as lithium ion, I guess.
And they're the same size or smaller than the lead acid ones. So.
Yeah, percentage of the weight, but they typically cost a lot more.
They're not that much more.
Really?
Like twice.
Oh, I thought they were a lot more.
Yeah. Like you can get like a 8 amp hour battery, which is probably about the size you're looking at. You can get it for about $20 and $25 for a good quality.
Where?
And I don't know. Whatever. I just did Amazon, but yeah.
Oh, Amazon, really?
Yeah.
I noticed that they used to be quite expensive some years back. The subject comes up in my model airplane work. It used to be really expensive. They've come down in price a lot because they're becoming of a lot more interest with the proliferation of E-type devices that need larger batteries, and people start worrying about fire risk, right? Explosion risk. So they're moving to phosphate a lot faster.
Yeah.
And so and also on these lead acid batteries, I realized that you needed one that does deep discharge, because otherwise you'll kill them pretty fast.
Oh, really? Huh.
Yeah.
There's a discharge option in those controllers. I've never really played around with them. I think I don't know. I usually date, stick a label on the battery to date it if it doesn't have some sort of date on it. And it seems like most of them, for like alarm system use and stuff like that, they'll last maybe 5 years, and then.
Oh, well, they're not charging and discharging like at night and stuff. Yeah.
Right.
Yeah. Like my lights are on at night. So.
Yeah.
And the gate opener probably has to open a few times, at night.
Or it might. Yeah. It stays maybe discharged until the sun comes out again. But yeah.
But I tried to over design it so that it could run for about 3 days in a cloudy situation.
Yep. Yeah, I think that's why they recommend the higher watt, or wattage panels, like at least a 15.
Yeah.
So you
I
can go.
20 watts are pretty good.
Yeah. Yeah. Like in Texas, they said the minimum should be 15. So I thought, okay, well, I got 2 7s. What do I have to lose? I'll parallel them up and see if it actually works. And
right.
So
and my house solar panels, you're right. When it gets hotter, then the peak output power goes down a little bit, but the width of the thing gets wider. So you're generating
Oh,
more
yeah.
energy.
You mean you have more sun hours?
Yeah, so we have more sun hours, even though it doesn't get as high, and so you get more watt hours out of it. But
Yeah.
Yeah.
Yeah. Yeah. And actually the highest output is like, really in the winter months, because it's cold, you know, and if you can get some
oh yeah, short days.
those
so,
days, you know, where the sun is pretty intense and it feels warm out, but the panels are cool, the air temperature is cool. So, but yeah, there's so do you have like a, you know, a fairly large array to power your house? And
it gives me, it's a small array, but it gives me maybe an average of 40% of my power. And
Okay.
in the winter months, in the spring, winter months, it can give me 80%. And in the
Okay.
air conditioning, I might get down to 30.
Oh yeah. Yeah.
And yeah, so where's the,
Yeah, mine will produce about maybe 55 kilowatt hours per day, which is, you know, and I think I was like the third or fourth customer on Fannin County Electric Co-op to actually have a solar array. And so the arrangement that you could make with them, you could get credited at the retail rate, not at the wholesale rate or the generation rate. So you know, the retail rate may be, well, it used to be like 11 cents or so a kilowatt hour. Now it's like maybe 12.4, I think. But at the generation rate, that's the rate that, you know, what it costs them to produce that power. It would be like maybe 5.5 cents a kilowatt hour.
Fat.
Yeah. So, you know, oh yeah,
so
you're, yeah,
so today
Oh,
I
got
got
one of
20,
those too.
I got 23 kilowatt hours. But
Okay.
my array is 3,500 watts. So
Okay. Yeah.
it's a small array. So my roof is real small. So yeah.
Yeah.
My house is like 3 stories, so it's tall and narrow.
Okay. Yeah. Smaller roof footprint, I guess.
Yeah.
Anyway, so I decided to go with the, you know, credit me at the retail rate, and you know, I'll just give you the excess, you know, if I generate more than I consume. And that's really worked out for us. And they, you know, we kind of got grandfathered in, and, you know, knock on wood, they haven't made any attempt to change that back or to say, nah, you know, we're gonna change the way we do this. So, but
Yeah. I was thinking of right now. They take my energy and give me back, but they charge me a higher price for kilowatt hours. You know, cents per kilowatt hour.
oh yeah, huh.
And I figured it might work. I think you can be a little lower overall cost if you get a cheaper kilowatt hours and just give them the extra energy. And that's what you're saying, I think.
Yeah, well, basically, yeah, in the months that I produce more than I consume, you know, I don't get credit from the power company for that. But every other, you know, all the other time periods, when I consume more than I generate, you know, I'm credited at the retail rate, not at the wholesale rate. So, or the generation rate. So it's much better. So, but yeah, knock on wood, I put it in 2013, took about 7 years to pay for itself. So that's, you know, 2020.
That's good.
That's good. Yeah.
Yeah.
Mine's like 12 years. it's a small
Well, I
array,
did.
but yeah.
For a while, right here, they were getting 80 cents a kilowatt hour on residential systems.
What?
Oh my God, really?
Oh, okay. Yeah, I paid way too much when it was 10 years or 6 years, 7 years ago.
The province of Ontario is paying huge premiums for early adopters. Huge premiums, as Pat says. That's gone now.
Mm.
Yeah, it is. So it was, if it was on your house, it was 80 cents. If it was remotely attached, so on your garage, detached garage, or on a post in the backyard or whatever, they were down to 61 cents at the time. Then they dropped to 57 cents a kilowatt hour. Now I believe they're fairly low.
Huh.
It's still a premium over the residential rate, depending here, it's time of use. So up to, I think the high rate is 14 or something, might be more than 14 cents a kilowatt hour.
Yeah. Yeah, so it's worked out. Knock on wood. It's the inverter has a 20-year warranty on it. So you know, and then you know, that goes out to several $1,000s. So
yeah, my inverter went out a couple of years ago. I was like, what the hell? But they replaced it for free.
oh, they did. Oh, that's good.
So hopefully my installer stays in business.
Yeah, right. Yeah.
Because I said, I'll just replace it myself, but there wasn't any way to transfer the warranty to me or anything. It was weird.
Yeah. The yeah, basically I there were several solar power international meetings, and one of them was in Dallas, and you know, I was curious, so I claimed to be a student, and you know, got the cheap entry rate, and my parents live in Florida, and then you know, one of the other shows was in Florida, and so I went to that, and so I became a dealer for Sologent, which is a distributor of you know, they sell to installers that so the, you know, I got a great rate on the panels. It was like at the time Canadian Solar 230s, which I mean, now they have, most of the panels are, you know, 300 at least or above for output wattage. So if I ever did replace the panels, I could, you know, I could probably get a lot more power out of the thing. But and I did, you know, I bought pretty much all the materials, did the installation myself, and so I didn't, you know,
that's how you got paid off in 5 years or 7 years. Yeah.
7 years. Yeah. Yeah. So
good. But
so it's worked out, but I still haven't used that one panel for any battery charging. So I gotta, so it's like, okay, I gotta hook this thing up. It's been long enough, you know. Anyway, so that's what I've been working on.
Well, thanks for the update, Ray.
Yep.
Thank you.
So has anyone else got something for tonight's meeting?
Yeah, you don't get that much, you know, the amount of solar radiation in Canada isn't that great though, is it? Because you're at such an angle to the sun, right?
Plus, I have what we call our mountain to the south of me, plus a lot of forests in behind my house. So I have a very poor location for solar panels.
Oh yeah, yeah, a lot of shadowing.
Yeah,
yeah.
I've got a good southern exposure, but it's in the winter. It's about 45 degrees or so solar panel angle.
Yeah.
In the summer, I think it's 23 degrees.
Yeah. Yeah. So if you're going to do a fixed array, you just kind of pick the median and.
Yeah, if you're going to do fixed, yeah. And my peak is the wrong way for a fixed array in the house. So.
Oh, it is. Yeah. Yeah.
My peak is north south.
Yeah.
But but it's cold up there, so they're more efficient.
Yeah.
Especially with snow on them.
Yeah. Yeah. 2 feet of snow on your panel.
2 feet of snow, yeah, they don't work that well. But it's surprising,
right.
A few inches, I believe they do still capture a lot of solar radiation.
They self-heat and then that melts the snow off.
Yeah. Yeah.
But,
Yeah.
In Dallas, the angle is 15 degrees, I believe.
No, mine's actually at 30.
Oh wow. Okay.
Yeah, you do it. It's pretty close to the latitude, I guess, right? Yeah, which is I think 33 or something around here.
Yeah.
But
33
Yeah,
from horizontal.
yes. Yeah.
Yeah. So
Yeah.
So in the winter I'm 45.
Right.
So
They should get the snow off quickly. Yeah.
and
Yeah.
or in the winter I'm 23, like from vertical essentially, and then 45 in the summer.
Oh, you
Yeah.
switch it. Huh? Oh.
Yes. So that's just the angle I put of that.
Mhm.
To capture full sun. I had a little setup in my back shed,
Yeah.
and it wasn't working. I had a 50-watt panel, and it was I ordered a 7.5 amp hour battery, sealed lead acid, and Amazon in their wisdom shipped me a 75 amp
Whoa.
battery, but it couldn't keep up, and the battery would freeze in the winter.
Oh, yeah.
So it eventually broke.
Yep.
I've had several small solar panel battery systems in my yard in my shed for many, many years. There's 3 or 4 of them out there. I didn't build them. They're commercial units and they're very small, but they have worked nonstop for at least 10 years out of doors with lithium ion batteries in them and solar panels stuck on the outside. They just work. They're for lighting. They just work well.
Yep.
I know what's in them. I took them apart. I'm a tinkerer. I can't resist, even if I bought it not to take it apart.
So did you get it back together?
Yep.
Okay.
And it still works.
And it's still.
Harold, did you have something to present with your giant Bic pen?
Yes.
Or a pencil? I don't know. Is
Yes.
it a pen?
It is
Oh, it is.
indeed a pen. This was this is the same guy who did the floppy dragon that I showed off a while ago. His name is Bearded Printer, and the only way you can get this pen is you got to become a member of his group. It's a whole $4 a month, and I paid him $4 a month, and I don't know if I'll pay him a second $4 because this is the only thing I was interested in. This is about 600 grams of plastic PLA set. I've got an Army. Actually, the color's not doing too bad, even though I don't have most of my lights on. I've got a this is Army beige, inland Army beige for the clip, and the clip does work, by the way. See, this is Starlight Nebula on this. The end here is something called Purple Star Stuff. It's expensive because it's cookie cat, but all of it's PLA. And yes,
Wow.
it does work. And that is indeed a big pen shoved in the end. The top of this thing, because I've already shown it off several times today.
Oh, the
It's
clicking
built
mechanism.
just like a clipping mechanism, just lots bigger. The internal ribs, see the internal ribs in there a little bit, hold all this stuff. This indeed does come off, but that is that. Just like a real pen would do this. This plunger thing here goes all the way through. You put this back together here before I go too terribly far. The nib comes off of this thing.
Wow, is that a 3D printed spring?
It is. This is just a standard crappy big pen. You can get 24 of these for 10 of them for 97 cents right now for your back to school days. It's slipped in here. This is a PET G printed spring, and it's not just printed, it's printed with the supports already modeled in. So when you print it off, your first job is to then cut the supports out of it to get your springy spring. And of course, like I said, this little black piece goes all the way through, and it literally screws together in 3 sections. This can be printed on an A1 Mini as a placer design. So if you have an A1 Mini, which is a 180 by 180 by what? I guess 180, 200, something like that. It's It's not much. It's somewhere around that way in the height. You can print this whole thing. It takes, I was just doing some math because somebody wants me to print it for them. It'll take about 24 hours total. Hold up. I'm lying. I wrote it down so I wouldn't forget, and I've already forgotten. Sorry. Yeah. It'll take a total of about 25 hours to print the whole thing.
Wow.
And you don't need a multicolor printer to do it because you're printing these two parts together and then the barrels together. This has to lay flat. And these two parts and the nib go together, and the spring and the pin holder are, and this top thing up here is kind of separate.
So do you have a pocket protector big enough to hold that thing?
Well, if I did, you may not. Yeah, no, I don't.
No.
I'm not big enough nerd to have one there, but and so that's that. And I made some more pins and that kind of stuff. I'm working on it. The other thing that may interest you people, I say you people. It took a Canadian and a Mainer to tell me that's going on in our own backyard. Not this month, but this month, a year from now, August 2026, we're finally getting a 3D expo here in the Dallas-Fort Worth area. It's going to be the Lone Star 3D Expo, and it's all going to be over the Irving Convention Center. The standard low-end table is $100. It's a an 8-foot wide table setup. So I may be picking one up just for me. I think the Richardson Makerspace is looking at picking up 2 or 3 of them for doing whatever they want to do. And I figure I can show up with my 3D printer, my 3D printed pins, and some of the resin casts. And I don't know if Bearded Printer will be there, but if he's not there, I'll make sure I represent, that kind of stuff. And that's going on. And the other thing, because we're some maker crafters, is that on the 23rd of this month, down in Waco is SWAT, which is Southwest Association of Turners, one of the largest wood turning conventions in the United States, is going down, and I intend to be there. And I've got some other stuff I've been working on the whole thing here. One of my community people was having a hard time with one of those things. What's one of those things? It's a DFR 0299, because I know how we love numbers in this group. What that really is an SD card that can go up to 32 gigs, and it's an MP3 player. So basically, you plug it in there. It's got its own speaker out. It's a mono speaker out. You get little buttons, or you can do a serial to it, so you get pre-canned audio. For like if it's something on one of your devices, you wanted to, hey, I wanted to say hello. I want to say goodbye. I want to say don't touch that. Those kind of pre-canned things. If you get those in MP3, stick them on this thing, and it even has folder structures in there, so you go crazy with the folder structure. I don't know how that works, and quite at all. I've only played with the very manual stuff. We're about to hook it up to an Arduino to see what we get. I'll make that thing for them. Yeah.
So you give it an I2C command or what?
No, it works over serial. It's an RxCX.
Okay.
RxCX on it. And I forget what I paid for it, but DFR was going away. I was buying a bunch of junk. I say bunch of junk. Stuff, very cool things that I haven't done anything with. So is that junk? I don't know, but that's yeah, maybe, who knows, right? And I was buying a bunch of these things just because it looked fun. I got some fire beetles and some other. I got a beetle with a 2040 in here and that kind of stuff, and things to play with. And I happened to get this. He happened to get it. He couldn't get to work on the thing, and I told him when I get around to it, now it's to it. I'd look at it and see if we could figure out his problem. And that's what we did Monday night. I didn't quite I got caught up to him, but I have not done everything. I haven't. This tomorrow night we'll be plugging this into Uno. Well, might be plugging it in now just to make sure a couple of things. We got Uno. The Metro didn't seem to work, and I got an ESP32, which is a real concern that we're going to plug it in there, do some things on it, and so that's what I've been kind of planning on doing. And I've been working on a pressure pot system for the makerspace, and it's almost done. We inherited a compressor that one of the Campbell Hausfeld's yellow Pro Series, and it's a slow RPM compressor. It's like literally like whoop, 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 whoop. That's as fast as it goes, but it works really well. However, I can't get it to shut off when it reaches its maximum thing. It'll just sit there and hang out. And I've been looking there, and I looked at the relay switch, and it's like I don't see anything I can really adjust on it, which is a problem. And then I got to thinking, well, what about the oil? And it's not an oilless thing. It doesn't have an oil reservoir anywhere near as I can tell, but it looks like it's got a piston sort of thing and a pulley sort of thing that looks probably needs some grease. And I can't even find a manual on the internet for the thing. I look up the part number, the whole works, can't find it. So I'll be looking at some more of that tonight before I go to bed. And so, yeah, nothing like dealing with old stuff that you inherit, and the person that knows what's going on has since passed, and so you get to figure out where the manuals are and where all the stuff is. Some of that's kind of fun, some of that's kind of sweet like, and some of it is just a whooping.
Mm-hmm.
So
Yeah, most of them for the high pressure point, it's a pressure switch.
Yeah,
It'll sense what the pressure is in the tank and turn it off.
yeah, it's a spring activated relay. I was looking for an adjustment screw where I could adjust on it. I've seen the spring. I've got the mechanism. I can, when I switch the thing on and off, I can see the spring tighten up and engage and relax, and I can see all that. And it looks all that looks like it's moving nice and easy and flowing like it's supposed to. But for some reason, when it gets up to the 129 psi, that's what it says on the side of the thing. And I'm looking at the gauge on there, and it said it's right at 129 psi. It was cutting off earlier, like about a month ago when I first got it, and I haven't used it in a little bit. And now I go to turn it on, and it just sits there and hovers right at 129, whether I connect anything up to it or not. It'll just sit there, and it'll just. What I'm afraid of, I'm not afraid of blowing up one of the pressure pots. I'm afraid that somebody will go in there to the makerspace, because no one ever uses anything, and they always pay attention to everything in the makerspaces, right? That somebody will leave this on, and it'll just sit there, and because it does has mechanical rotating things. It's not like those airless things where it's got the little diaphragm and the pump thing, right? And it has those things. It's got a piston in it. You can hear the piston. You can do that. There's got to be some lubrication somewhere. And I can just see somebody turn that thing off, forgetting to. It makes a bunch of noise, but they could still just leave it on, leave and come back, and an hour later the thing is seized up, and now we have a busted piece of equipment that could have been avoided if I could figure
Burnt out motor,
yeah. And then when it's burnt out, that's just a pro line kind of a thing instead of the $200 thing. I bet when they bought this thing, it was a $500 or $600 unit, even though it's a 3 gallon. It's a 3 gallon long, single long cylinder. But because
hot dog compressor.
What now?
A hot dog compressor.
A hot dog compressor, yeah. And because it's got the yellow on it, and it's in the Pro Series of Campbell Hausfeld, which makes pretty good but also expensive equipment. I bet this thing was a high dollar thing when this guy first picked it up. I'd like to not have to replace it, because I got a compressor that'll do it over here, but it's one of those Harbor Freight blue ones that is oilless, and it makes a hell of a racket. It scares the crap out of you when it goes on. Well, the wife jumps across the room, but as funny as that may or may not be at the time, it might be funny to me, not so much to her. But it's not as efficient and as fast as this one I've got here as far as powering up. Because one of the things I got to do is I got to keep at least 40 psi on these pots, and one of the biggest mistakes you can make is not pre-charging your air compressor when you start filling up the pots, because then it takes too long and your resin starts hardening up and getting bubbles in it before you can get it under pressure. So things that you learn that you never thought you needed to learn. Like, this is artsy-fartsy craft stuff, man. What do I need to know with resin? But there's lots of fun stuff, man. Learned lots of fun stuff with this stuff. I mean, to the point where, you know, if we come up with an idea that we need to, I know you got some CNC machines out there, that sort of thing. I feel pretty confident that if we needed to do some stuff where we would mold some things and make some cool shapes and that kind of stuff, I haven't done one of those yet, but I feel pretty confident if somebody's got a project that wants to do that to make some cool features or something, we can make that happen, man. That'd be fun. We need to make it look cool with cool colors and crap like that and swirls and stuff. But
I thought for most casting things though, they applied a vacuum to it to suck out air bubbles and stuff. No,
it depends. It depends on the type of thing you're casting at. I'm getting old. I'm gonna sit down here. All right. If I don't want to get too deep because we'll be here all night talking this noise. You got epoxies, urethanes. That's your basic, and you got polyester, polyurethanes. Those are your three basic types. And then you have mixtures of those, just like that 5-minute epoxy you have at your house right now. You put it together in 2 liquids, you mix it together, and in 5 minutes, the thing sort of hardens and solidifies, but it's not really cured for another 24, 48 hours, something like that, right? So the same thing with these casting things is that depends on the epoxy or the substance you have you're mixing. The ones I like that everybody uses for their label cast, which I'm going to use too, it's got a 7-minute open time. So when it takes you 30 minutes to get all the air out of an epoxy liquid, you don't have, and you got 7. Guess what? You're not doing, right? You're not vacuuming now. There's some stuff out there that has an 1.5 hour open time. At that point, vacuuming it out is a wonderful thing to do, because what you're probably going to do with that, not do pins like I'm doing, is you're going to make river tables and pour big swaths of stuff, and you want to get most of the air out of it that you can. So when the bubbles start rising to the surface, you just have a little bit of that to take care of. A lot of that stuff is self-degassing these days because it cures so slowly. And there's there's a lot of stuff out there that I find are somewhere between 15 and 30 minutes, depending on the brand name and the formulation. So if you have time, vacuuming works really well, but it sometimes takes 20 or 30 minutes to get the process going and get enough suction on that to get the air coming out. So instead of sucking the air out, and then when you go to pour it back in, some air will get back in, but it'll be much less that's in there. So instead of sucking it out, these guys get up and pressure it up. So at 40 psi, my wife was giving me the eyeball over here.
7,000 steps.
Yeah. So at 40 psi, that's like what, 2 or 3 atmospheres. So however big the bubble is, it's going to be reduced by half of 1 atmosphere. Another atmosphere will reduce it by half again. Another reduce will be another half of that. So in about 3 atmospheres, you got bubbles that we can't see for the most part, and that's how that works.
Okay.
Yeah. And I got tons of mica powders, so we can put swirly swirls and color stuff and sparkles and way more artsy stuff than I ever thought I was going to get in the big old middle of. Yeah, I'm happy to demonstrate that and talk about that at some point, but it's not really robotics, but it is. For instance, in our case about robotics, let's say you wanted a cool shield or something that, you got a 3D print, you can print it, but as strong as your 3D print is, it's going to have layer lines, delaminations. What if we could 3D print the thing you wanted to get a mold, and we could mold it up, and then we pour this epoxy in there, drill out a couple of holes and mount it on there. Now I've got a polyurethane bumper. Let's go run into something.
Yep.
But we can certainly use all the other stuff before we get to this point and pouring this thing, because usually that epoxy does anywhere at demold times, meaning you can pick it up out of the mold and it shouldn't stick to your fingers. Anywhere from an 1.5 hours to about 24 hours, depending on the formulation. But even with the 1.5 hour one, it's a good 5 days before you want to cut on it, manipulate it, any of that thing. It's got to fully harden in there. What's going on? all kinds of fun stuff, man. We go for a long time on
Mhm.
just what I know, not what I've done, but what I've seen and accumulated, and I want to try. I don't know.
Yeah.
Fun stuff.
You're talking about the Turner's Club. There was a meeting that used to be over in Fort Worth, and I'm not certain what kind of wood it was, but this guy could make it so thin. He made wooden cowboy hats, and
Oh, wow.
he could even curl the edges up on the side of the hat if he wanted to, or just have it just be a straight brim. And
Wow.
it was actually fairly light because it was so thin, and not a pretty wide brim on the thing. So it's like, you make one mistake, catch the tool, rips half of the brim off. Or
That's what I'm learning too. I mean, I've been watching these people, and some of these people, they've been turning since they were kids, and they're old. They're old as I am, and they've been turning since they were 10, 15 years old, whatever it was. And you'll set them watching. They'll be doing a live show or a live stream, and doing the same things that I'm doing. I'm like, yeah, I'm doing all that. All of a sudden, whack, it blows up. Okay, well, that's we can start over, but I don't have time enough. I got to go for the next time. It just happens. You just got to be prepared. I mean, when I do everything I do in the resin casting and the pin turning, and I'm doing the 3D printing. I'm 3D printing blanks and molds to do hopefully make cool pins that don't exist in nature, and with designs and people's logos and all that other kind of stuff. And even then, every time I make one of those things, I make two of them. I never just make one blank of the thing, just because it's just probably gonna blow up. And when it doesn't blow up, great. That means I get to make another pin of it, and I got a bonus. That's the way I look at it, anyways.
Mhm.
yeah, I had a bunch of spalted wood. Really kind of, I probably should have, mounted it to a thicker piece or glued it, a piece on the end of it that I could mount onto the lathe, but I didn't. So I'm in there turning and catch it with the tool, and it yanks it off the lathe, and it basically throws it at the back of a lease car that I got when I worked for Hitachi, and put a pretty good dent in the trunk of the car. It's like, you had to explain that. It's like, yeah, it was hit by a wooden bowl that flew off my lathe.
Yeah.
So
The thing to do with that spalted top wood, because it's kind of light, right? And it's got a bunch of air holes and pockets and stuff. And I'm not played with much of it. This is, again, seeing a bunch of stuff, doing a bunch of research, prepping to do this stuff. Is you want to do something called stabilization.
Yeah.
And that's a fun bit of stuff, and that does use your vacuum all over the place. You're right.
Yeah.
And it's a heat cured resin, and your idea is you get all the water out of the thing, you put this thing in nothing but the heat cured resin. You just put a vacuum on it to pull all the air out, and then let everything that comes out is going to get stuck back in. And what you're going to do is, since it's in the resin, all the resin gets sucked in the holes where the air was.
Yeah.
And you take all that and you cure it up, and you effectively got your same wood, but now it's encased in some kind of epoxy, in a solid thing. Yeah.
Yep.
Yeah. I don't have one of those pots yet, but I've done some research, and I think I've got a mold over here where I can put a piece of thing on top of one of my pots, and I get me a piece of a plexiglass, put on top, or a big thick of acrylic, and I can make me one. I've got me some, lots of learning. I still got a long way to go. It's amazing. It's amazing how I just wanted to make a pin out of printer poop, out of reused plastic, and now I've gone way deep in this particular rabbit squirrel hole. So, of course, I'm picking up more fun stuff along the way, and that is fun. I mean, the more skills I have, the more interesting problems you get to work on, and interesting solution you get to come up with. That's why, in fact, it didn't occur to me until I got here and started talking to you folks that we could probably make some really cool looking molds and things like that for front ends, or in the case you have a manipulator that needs to be extra strong but extra light. We could, if we can get it where we can mold it up in any way, shape, or form, we can probably put some urethane to it and make it fairly strong. Probably. I don't know for sure, but it'd be something fun to try. Something fun to try.
Anybody molding carbon fiber?
I don't know anybody doing that.
Oh no. Okay.
I don't know anybody doing that.
Yeah.
I mean, you get the PLA. They got this carbon fiber impregnated filament for printers. And
Mhm.
some of that's some really high dollar stuff. Some of it's got enough metallic things in it, so if you were to print a bell out of it and then thump it, it sounds like you're ringing a bell. It's got so much stuff in it, but that stuff's expensive as all get out. We're talking here $150 a roll or so, $200 a roll, something insane. I haven't looked at it in a while just because I know it's insane and I'm not going to look at it. But there's a lot of that filament out there in the functional space that has some level of carbon fibers impregnated in it or dispersed in it, and some of that can be fairly strong. Or some of it's got carbon into nylon, which nylon is strong by itself, but then you put the carbon fiber bits in there. If you're able to print it, it's pretty tough to print. I understand. It'd probably be pretty strong. And that's about the closest I got for molding of the carbon fiber things.
Yep.
And even that's not as strong as the real mold, right? Because you got these little strands, and when you're squirting them out, hopefully enough of them line up to give you the strength, as opposed to carbon fiber where there's a continuous strand in the whole sheet as you're pushing it on the mold. Oh man. I don't even know how I know all that.
All right. Well, I'm going out. Bye.
You're heading out. It's probably,
Yeah.
should we call it?
I think so. We've been off topic for a while, so.
Yeah.
I'm good for that. I'll off topic everybody. So I'll find
Oh,
out.
well.
Okay, well, thanks everybody.
Thank you.